Good morning, all. So, hope everybody had breakfast and ready to go with the session. And before commencing, let me know whether my voice is audible now. Morning, we had poor network, so I was not able to had a session. But right now, let me confirm whether my voice is audible. Me, not yet. After the session, I'm going to have. Thanks for reference. I didn't get reply whether my voice is audible now. Okay, Sandhya, then. In this session, we are going to start a new chapter, that is light. Under that, we have only refraction of light. It starts from page number 81. Only that part we are going to have in this board examination. We need not to go through the mirrors. It is only concerned with the lenses, spherical lenses. So we all know that when we stand in front of the mirror, we can see our image. Right? And sometimes if you see some objects placed in a glass filled with the water, what you're going to observe, if there is a coin in a glass filled with the water, what you're going to see, when you see from the topmost area, you find that the coin is raised above. It is raised above, isn't it? In the same way, when you place a pencil in a glass filled with the water, what you're going to observe? You're going to observe the pencil has bended. Now, what is the difference between these two? Any idea? Any idea? Let me see who is going to answer for this. What is the difference between the first example and the second example? Okay, no reply. I don't think that you have idea on this, but it was there in 8th standard. I think everybody forgotten those concepts. It was there. It was there at 8th standard, and you worked with examples also, ray diagrams also, but still no one answered. Okay. I'll share the screen. You just observe it and tell me what happens. Okay. What you're going to observe here, with the help of torch in a dark room, a torch has incidented on a glass which is filled with the water. You can see that the torch light ray has bended. Where? In the glass. Then, when the ray comes out from the glass, again it starts bending. Could you able to find out the difference here? The first, the ray of the light is in air medium. Then it enters into water medium. And then again enters out into air medium. Okay, could you able to find out this difference? Okay, everybody, could you able to find out the difference? There were different mediums. I'm not getting any reply from your side. Okay, could you able to find out the difference? So diagram ಮೇಲೆ ಅವಲಂಬಿತವಾಗಿ ನಿಮಗೇನಾದರೂ ವ್ಯತ್ಯಾಸ ಕಂಡು ಬಂತಾ? First thing, the torch light, when it falls on the glass and then when it enters into the water medium, what happens? At least could you able to answer for this question? What happens when the light passes from air medium into water medium? What happens? No Aishwarya, I need what happens. ಏನಾಗುತ್ತೆ ಈಗ ಇನ್ಸಿಡೆಂಟ್ ರೇ, ಫಸ್ಟು ಲೈಟ್ ಬೀಳೋದನ್ನು ಇನ್ಸಿಡೆಂಟ್ ರೇ ಅಂತ ಕರಿತೀವಿ. ಎಲ್ಲೋಗುತ್ತೆ? ವಾಟರ್ ಮೀಡಿಯಮಲ್ಲಿ ಹೋಗ್ತಾ ಇದೆ. ಹೋಗಿದ ತಕ್ಷಣ ಸ್ಟ್ರೇಟಾಗಿ ಹೋಗಿಲ್ಲ, ಬೆಂಡ್ ಆಗಿದೆ. And what is this difference? One is air medium, another one is water medium. ಏನಾಯಿತು ಅಲ್ಲಿ? The ray of the light bends. This is the answer. Bending of the ray occurs when it travels from one medium to another medium. Is that clear? Yes, Arshita, your answer is right. Bending takes place. Okay, everybody clear with this? Okay, I quoted one example. When you stand in front of the mirror, you can see the image of yourself, right? What happens there? It is reflection. The phenomenon takes place as reflection. Okay? Now what happens in the second example? When you pass a ray of light from the air medium into water medium, the ray bends. The ray bends. And this phenomenon is known as refraction. Refraction. Okay, is that clear? Okay, this concept is too difficult to explain live, but still. Okay, these concepts were taught with the help of diagrams. Okay. Okay, now let me clear with these two concepts what is reflection and what is refraction. The reflection is just bouncing back of the light. The light which falls on the surface is called incident ray. The ray which bounces back, and that ray is called refraction. Reflected ray. Now, what happens here in the reflection? The angle of incident is equal to the angle of reflection. Always remember, the angle of incidence is equal to the angle of refraction. Okay? This is about reflection. It is not there in your syllabus. It is only for knowledge wise. Now we have the concept refraction. What is refraction? We have in the syllabus for this board exam is only refraction. Now what is refraction? Can you able to conclude some definition from the example which I quoted? Two examples I quoted. When you place a torch light on a glass having the water, it bends. And again, when the ray comes out from the glass, again it bends. Okay, this is one example. One more example is, take a glass of water, place a pencil, and just you have a look from the side. What you observe? You can find a bending of the pencil, right? Now, what can you conclude from these two examples? Fashion Zone vlog. Thanks for visit. Thank you so much. Okay, I'm not getting any reply. You just conclude in 1 or 2 lines. Hi, good morning. Good morning, so sweet. And the session is completely professional. I'm dealing with science class. Thanks for your visit. Thank you so much. I didn't get any reply for my question. I gave 2 examples. When you place a torch and when you let the light of the torch to fall on a glass, it starts bending. And when you take a glass of water, when you place a pencil, and if you have a look at the side, even that pencil looks bending. Now, what conclusion could you able to draw from these 2 examples? No, Sumangala, no, your concept is entirely different. It is not related. No other answers. Why today so much of silence? No reply today. Okay, because this is new concept, so no one is able to answer. Okay, let me go with the explanation. Now let me confirm, when I share the screen, my voice is audible? Okay, again I'm going to share the screen. You just have a look. Now this is the image where the incident ray, that is the starting ray, falls on the glass slab or the beaker. It starts bending. Why? Outside the glass slab, it is air media, and the glass is, again it bends. Okay, Arpita, so fast. She gave the refraction law itself. The law is, okay, if something buffering, it is your place network problem, but here it's too good. Now, okay, I'll explain now. When the ray passes from air medium to the glass medium, now remember, air medium is light and glass medium is denser. So, when you draw a line, a straight line between the incidence ray and refracted ray, you will get a normal line. Okay. you will get a normal line. What happens here when the ray passes from incident ray to a refracted ray? If you draw a normal line, the bending is towards the normal line. The bending is towards the normal line. In the same way, when the light passes from denser medium to the lighter medium, that is from glass to the air, from denser medium to the lighter medium, when you draw a normal line, what happens there? The bending is away from the normal. The bending is away from the normal. But still, the common concept is when the light travels from one medium to the another medium, then the light bends, or you find obliqueness, and such phenomenon is known as refraction of light. I'll repeat. When the light one medium, light travels from one medium to another medium, then the light bends, and this phenomenon is known as refraction of light. Okay, whether this concept is clear for you all? Okay, plant diary. Yesterday entered your channel. It was so amazing. Full details of the plants and very good uploads. And thank you so much for your visit and also for your comments. Thank you so much. Okay, thank you. Thank you for your visit and also for your comments. Okay, whether the concept is clear, very simple. It bends, simple, and such phenomenon is known as refraction of light. Or the other way is when the light travels obliquely from one medium to another medium, and that phenomenon is known as refraction of light. You can consider both definitions. Network problem. Okay. Mate. Now what happens here? Now place a pencil in a glass containing water. You just see the pencil in the air medium and you just see the pencil appears obliquely when you see from air medium to the water medium. The pencil looks obliquely when it moves from air medium to the water medium. This is known as refraction. This is known as refraction. Now you can have a look on this image. The incident ray passing from air medium to the glass medium. Air medium to the glass medium. What happens when the ray of light passes from air medium to the glass medium? You all know that when you draw a straight line between the incident ray and refracted ray, that is called normal ray, normal line. The angle of incidence I, you just look at angle I, that is from the normal line to the incident line is called the angle of incidence. Remember, the angle between normal line to the incidence ray is called as the angle of incidence. And you just look at glass slab. The angle of refraction is between the normal line and the refracted ray. The angle between the normal line and refracted ray, and that angle is known as angle of refraction. Okay, here we can have a law, and the law is the angle of incidence and the angle of refraction. The two angles are the angle of incidence and the angle of refraction. Now what we can conclude from this, the ratio of sine of angle of incidence to the sine of angle of refraction remains constant. Otherwise, the ratio of sine of angle of incidence and the sine of angle of refraction is constant. Okay, too much of network problem in your area, but I don't have any problem right now. Morning I had problem because it was so cloudy because of mist. It was poor network, but now it's okay. I could able to communicate. Know that the ratio of sine of angle of incidence to the sine of angle of refraction is always constant. And how to represent this? Sine I by sine R is equal to constant. Sine I by sine R is equal to constant. Okay, then I'll go with another law, the law of refraction, that is the incident ray, refracted ray and the normal to the interface of two transparent mediums all will lie in a same plane. The other law is sine I by sine R is equal to constant. That is, the ratio of sine of angle of incidence to the sine of angle of refraction is constant. Okay, these are the two laws of refraction. The incident ray, refracted ray, normal line of the two transparent mediums always remain in a same plane. This is first law. And the second law is the ratio of sine of angle of incidence to the sine of angle of refraction remains constant. Okay, cleared? Is that cleared? Shall I continue? If it is audible, I'll continue. If not, we'll end the session. Why so much even for kids? Now I muted Dikshita. I am not asking right now. I was asking till now whether you could able to hear me. Yeah, sometimes it happens, the break in the voice. And many of the participants were complaining that they were not able to hear because of poor network. And few they can hear. Okay, those who were heard clearly, let me know what is refraction of light. Come on, get me the reply for this question. Okay, Rajini has also no problem. She can hear me. Okay, now tell me what is refraction of light. Put in a simple way so that I can move for next concept. Okay, no, the meaning is same for the Dikshita. What you gave, the meaning is okay, but you should put in a simple way. That is, when the light travels from one medium to another medium, it bends. This is one definition. When light travels obliquely from one medium to another medium, then it is called refraction of light. Okay, these are the two ways you are going to represent your answer. Okay, hope a few people has problem and many of them they can hear me. And we also gone with two more concepts, that is, when you see the light hits on the surface, that light is called, what is the name given for that light? Come on, reply for the question. When the light hits on the surface and you just draw a normal line, and what is the angle formed between the normal and the incident ray? What is the name of that angle? When the incident ray hits on the surface of another medium and you just draw a straight line, that is normal line. Okay. Now what is the name given for the angle between the normal line and the incident ray? I'm not getting any reply from your side. Okay, I'll go with Kannada now. ಇನ್ಸಿಡೆಂಟ್ ರೇ ಒಂದು ಮೀಡಿಯಮ್ಮಿಂದ ಇನ್ನೊಂದು ಮೀಡಿಯಮ್ಗೆ ಹೋಗುವಾಗ ಅದು ಹಿಟ್ ಆಗುವಂಥ ಸಂದರ್ಭದಲ್ಲಿ ಅಲ್ಲಿ ಒಂದು ಸ್ಟ್ರೇಟ್ ಲೈನ್ನ ಹಾಕಿದಾಗ ಆ ನಾರ್ಮಲ್ ಲೈನ್ ಮತ್ತು ಇನ್ಸಿಡೆಂಟ್ ರೇ ಮಧ್ಯೆ ಒಂದು ಆ್ಯಂಗಲ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಆ್ಯಂಗಲ್ನ ಏನಂತ ಕರಿತೀವಿ? ನೋ that is process. When it bounces back, then the process is called reflection, Aishwarya. I'm not asking the process, I'm asking on the angle. Angle of incidence, the angle of incidence, and that angle of incidence is referred as sine I. Okay, and when the light comes out from the glass slab into air medium, again you will get a refracted ray, and you just put a normal line, straight line, and then the angle between normal line and the refracted ray, that is emergent ray, what is called that? What is that angle called? Yeah, Rekha, partially correct answer. That ray is called ray of refraction. Ray of refraction. And also it is referred as sine R. Now, the law formed on the angles is sine I by sine R is equal to constant. Sine I by sine R is equal to constant. This is called Snell's law. And this is called Snell's law. The ratio of sine of angle of incidence to the sine of angle of refraction always remains constant. This law is referred as Snell's law. This law is referred as Snell's law. Is that clear, all of you? Yeah. Yeah, Rekha, even that is also correct. Not ray, angle of emergent. Even that is also correct. Share the screen. You just go with the screen. Now look at the diagram. And look at angle of incidence I. And then look at angle refraction R1. And again, when you come down, again you just look refraction, glass medium, refraction takes place, that is I1 R1. And again, when the angle of refraction remains constant, sine I1 by at another area, that is sine I2 by sine R2 is equal to constant. And this is the law of refraction. And that is known as Snell's law. All of you clear with that? Okay, when I shared the screen, the voice was not audible. Okay, I'll explain once again. When you saw the diagram, page number 83, you just go with page number 83. E is E to F. This is angle of incidence. Touches at O. And the emergent ray, that is the angle formed is R1 and I1. Okay. How we can apply the law of refraction? The Snell's law can be applied here. That is sine I1 by sine R1 is equal to constant. This is the Snell's law. And one more time you can apply the Snell's law, that is sine I2 by sine R2 is equal to constant. This is called as law of refraction. Okay, cleared? Okay, in the glass lab, when you draw the diagram, the angle of incidence, angle of refraction and the normal line all will lie in a same plane. All will lie in a same plane. angle of incidence, angle of refraction and the normal line all will lie in the same plane even though there is change in medium. This is also the law of refraction. Okay, there are two laws of refraction. I'll repeat once again. The angle of incidence, normal line, and the angle of refraction with the two different mediums will lie in the same plane. This is first law. The ratio of sine of angle of incidence by the sine of angle of refraction remains constant. That is, sine I by sine R is equal to constant. These are the two laws of refraction. So this is very important for your board exam. Definitely this question will arise in your board exam. The laws of refraction. Now at least is that cleared? Okay, if it is cleared, you just have a look on same diagram, page number 83. Now, this will be there for your examination. You have to practice this diagram, glass lab. Okay, now look at first refraction. Sine I by sine R1. Sine I1 by sine R1 is equal to constant. This is called Snell's law. Okay, now E and F is incident ray. And in the glass lab, R1 is the refracted ray. Okay. And N and N dash is the normal line. Okay. Now, the incident ray starts bending when it's moving inside the glass slab, right? Now, what is the difference between these two mediums? The incident ray is in air medium and the refracted ray is in glass medium. Air is always lighter than the glass. Okay. Now, you just look at the image, page number 83. The refracted rate is always towards the normal line. R1. You just observe the R1. The refracted ray is towards the normal line. ಹೇಗೆ ಬೆಂಡ್ ಆಗ್ತಾ ಇದೆ? R1 angle observe ಮಾಡಿದಾಗ it is towards the normal line. It is towards the normal line. Okay. And you just look at another refraction. I2 and R2. And you just draw the normal line. Okay. Now, from where the light is passing? From glass medium to the air medium. I1 is air medium. But I2 is glass medium. Now we are in glass medium. I2 is in glass medium. And now emergent ray. Where it is? It is in air. R2 is in air. Now, what is the difference? I2 is glass. R2 is air medium. From where it is moving? Glass medium is denser medium. Air medium is lighter medium. The ray is traveling from denser medium to the lighter medium. Hence, you just look at R2. It is moving away from the normal line. R2, the refracted line is away from the normal. But in the first one, it is towards the normal. Okay. And when you see that, the first incidence ray and the second emergent ray, when you draw a dotted line, always the incident ray is parallel to the refracted ray. You just observe the line, dotted line. Could you able to find the dotted line is always parallel to the emergent ray? Okay, I'll just show the screen once again. You just have a look. So again the refracted ray and O to O dash. Okay, and then L to P and O dash to H. Now what happened here? The ray of incidence and the final ray of refraction are parallel to each other. They are parallel to each other. Hope the concept of refraction through the glass slab, a rectangular glass slab, has been cleared. Should I repeat any concept in this refraction and the laws of refraction? Anything to be repeated? Okay, sorry for the break. Now, if the concept is clear, shall I put the questions now? Okay, what is Snell's law? Put in a simple way. What is Snell's law? Let me see who will answer. What is Snell's law? Put in a simple way. I'm not getting any reply from your side. What is Snell's law? Okay, I'll repeat the concept. The ratio of sine of angle of incidence by the sine of angle of refraction remains constant. That is, sine I by sine R is equal to constant. This is one law. Okay. The other law of refraction is the incident ray, the refracted ray, and the normal to the interface of the two different mediums remain in a same plane. All will stay in a same plane. Okay. Now this is another law of refraction. These are the two laws of refraction. Okay. My next question is from lighter medium to the denser medium. How the refraction takes place, bending takes place compared to the normal line. Okay, if it is not audible, I can't do anything. Okay, so if it is cleared, then in the next coming up session, you want to answer for the questions. What are the laws of refraction of light? Okay, and what happens when the angle of incidence and the angle of refraction passes from lighter medium to the denser medium? And what happens when the light travels from denser medium to lighter medium? Okay, so what is refraction of light? Now you should get ready for these questions. Okay, clear? Okay, the answers are: what happens when light travels from lighter medium to denser medium? The refraction of light is towards the normal line. Okay. And what happens when the light travels from denser medium to the lighter medium? The answer is the refraction of light or bending of the light is away from the normal line. Okay, and what are the two laws of refraction of light? The angle of incidence, angle of refraction, and the normal line between two different mediums all lie in the same plane. And what is the other law? The ratio of sine of angle of incidence by the sine of angle of refraction remains constant. That is, sine I by sine r is equal to constant. These are the answers for the above questions. Get thoroughly through these questions, and in the next session you are supposed to write test on these questions. Okay? Okay, we'll wind up this session now. Okay, and you just go with these questions without fail. So we'll meet in the next weekend. Thank you for the visit and editing the session and for responding. Thank you one and all. Hi, Vinita and Muskan. We just ended the session. Okay, you can go through the link afterwards. This is the chapter which you learned in 8th standard. Now it will be useful for your 10th. Okay, go through the link without fail. If the network is good, I'll handle the class at 3:30 for 9th standard. Okay. Okay, see you all soon. Thanks for your visit and for your good responses. And this time I was not satisfied with your responses. Please pick up yourselves and get ready for next session. Thank you. Thank you, one and all.